Okay, part 2 of day 1 is multiplication and division of rational expressions. So the biggest thing here is that you are going to be factoring a lot and canceling a lot, and then writing the disclaimer. So factor, cancel, factor, cancel. It's just like simplifying, where we factored, canceled, wrote our disclaimer, just we have a multiplication sign here. That multiplication sign, when we have two fractions, we can really just think of it as one fraction, and it's being multiplied like this. Okay, so they can all be on one fraction because you multiply the top and you multiply the bottom. So instead of actually multiplying b times each of those, we want to factor and cancel to make it easier on ourselves first. Okay, so I'm going to factor that first one, b squared plus 5b minus 24. So we have b, and that 24 were factors of 24 that add to 5. So that's going to be 8 and 3, and we want it to be a positive 5, so positive 8, negative 3. Then on the bottom, this is a special factoring pattern actually. B minus 3, negative 3 give me positive 9, and add to give me negative 6. And I have a b. And then this is a difference of squares, so b minus 8, b plus 8. Okay, so we factored, check. Cancel our common factors. So this can be across both of them. So remember, this can all be one fraction. So we have a b plus 8. I'm going to change the color here. So b plus 8 we can cancel. And we have a b minus 3 that we can cancel. We can't cancel this other one here because there's only one on top. So we can only cancel one on bottom. So then we are left with b on the top, and on the bottom we have b minus 3 and b minus 8. Okay, when we write the disclaimer, we have to include all of the values that were up in this row. Okay, so b can't equal 3, it can't equal 8, and it can't equal negative 8. And then that is my final answer. Okay, let's try a few more. With division, to make this easier, we're going to make it multiplication. So when we think about division, like if I do 10 divided by 2, that's the same thing as, so written 10 divided by 2. That's the same thing as 10 times 1/2, right? So when I have writing something like this, 10 divided by 2, it's the same thing as multiplying by the reciprocal. So this 2, the reciprocal of it, is 1/2. So I'm going to make this multiplication, and I'm going to flip that fraction. Okay, so I'm going to make this 5b minus 10 over 7b minus 28 times 5b minus 20 over 2 minus b. So I'm flipping that second fraction. Now it's the same as before. I want to factor, cancel, and then write my final answer. Okay, so factoring first, this top fraction, this top numerator I should say, over here, I'm going to take out a 5, so b minus 2 is left over. And on the bottom, I'm going to take out a 7, so b minus 4 is left over. And then on the top over here, I'm going to take out a 5, so b minus 4 is left. And on the bottom, it's 2 minus b, so think about when I had over here, I had a b minus 2. Remember, I can take out that negative to make it b minus 2. Okay, the negative of negative 2 minus b, plus b, is b minus 2 when I take out that negative. Okay, so now we're going to cancel. So this -2 cancels with that one, b minus 2, sorry. And then b minus 4 and b minus 4. So I'm left with, on top, I have a 25 over 7, and that's a -7. And so that's negative 25 over 7. That negative sign can go anywhere. And then our disclaimer, everything that is in the denominator, including the denominator from the original, like we need to look at the denominator in the original problem. So the denominator in the original of this second one was b minus 5b minus 20, which ended up being b minus 4. So everything canceled. So I look at the denominators here. So b can't equal 4 and b cannot equal 2. So we have to look at the denominators from the original problem and now to make sure that everything is covered. And the original one, 4, is what would have made that 0. So everything is covered here with 4 and 2. Okay, and one more example. I'll have you try this one on your own. Okay, so again, we're going to, since this is division, we're going to flip this one. And something else to look at is that this is, notice a difference of cubes. So it's going to follow that form of a minus b, a squared plus ab plus b squared. Okay, so we're going to flip everything. So I'm going to write a squared plus 3a minus 28. Not everything, sorry. A squared plus 5a minus 14 times a cubed minus 8 over a cubed minus 4a squared. Okay, so we flip it first. Now we want to factor. So factoring the numerator of this one, a plus 7 and minus 4 to give me a negative 28 and add to give me 3. And on the bottom, we have plus 7 and negative 2 to add to give me 5 and multiply to give me negative 14. On the top up here, my a and my b, my a is just a, my b, so what's cubed? So a cubed minus b cubed. 8 is 2 cubed, so a is a, b is 2. So we have a minus 2, and then a squared plus 2a plus b squared. And something to help you remember the signs there, remember, is the acronym SOAP. The signs will be the same, opposite, and then this last one is always positive. So same sign, opposite sign, always positive. And then on the bottom here, we're going to factor out an a squared, and I'm left with a minus 4. Now it's time to cancel. My favorite part. This part is so satisfying. You've done all this work, you've factored it all. Now we're going to cancel. Gone. 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 And that's all we have. Notice that this a squared plus 2a plus 4 cannot cancel, like you can't cancel these a squareds because this is all one factor. It has addition. So I have to leave it all together. You can't cancel if it's not all multiplication. Okay, so I can't cancel those a squareds because think of these as being all one unit. It's attached to those other ones. Okay, when it's all multiplication, like these are all multiplication over here. So you have to leave it like that. So you can't cancel. Okay. And then our disclaimer. So we look at all of our denominators of the original and now. So it looks like the a squared would be a 0. I'd have a -7, a 2, a 4. And then if I look back at the original one, that was this, and I had an, that's what this ends up being. So a minus 2, that's covered. A squared plus 2a plus 4, that's part of the original denominator. A squared plus 2a plus 4 is never going to equal 0. That part is going to give you imaginary zeros. So you don't need to worry about it. Because if I look at 2 cubed minus 8, that's the only thing that's going to give me a 0. So this is my final answer. Okay, so that's the end of part 2.